right, we're going to continue our discussion on sketching graphs of polynomials using a concept we learned in our quadratics unit. And that concept is that factors, when set equal to 0, give us x-intercepts as long as they give us real solutions. So we're going to try to sketch a quick graph of y equals x cubed minus 2x squared minus 15x. And we're going to use both what we learned in the last video about the general shape of a polynomial and what we learned about setting factors equal to 0 to get a quick sketch of this polynomial function. So I've intentionally chosen a function that factors easily, but if you had a polynomial that didn't factor so easily, we've learned a few methods and we'll learn a few more to learn how to factor this. But this one, I can just take out the common factor. The common factor is x, and that leaves me with x squared minus 2x minus 15. Now, that quadratic then factors, and it factors as x times x minus 5 times x plus 3. These are what are called linear factors because each one of those factors has a highest power of 1. Each one of them is in itself a linear polynomial. This is a polynomial in completely factored form. I don't have any powers of x at all in my polynomial. So now, if I set all of these factors equal to 0, x equals 0, x minus 5 equals 0, so x is equal to 5, and then x plus 3 equals 0, and x is equal to negative 3. Well, what does that give me? That gives me my x-intercept. So let's put them on the graph. X equals 0. I have an x-intercept right here at 0. X equals 5. I have an x-intercept right here at 5. And x equals negative 3. I have an x-intercept right here at negative 3. So what else do I know? Well, I know that my leading term here is x cubed. That means that I have an odd degree, the 3 is odd, and I have a positive leading coefficient. My leading coefficient is 1, and that's positive. So that tells me the end behavior of my function. It tells me that I'm going to go down to the left. As x approaches negative infinity, y approaches negative infinity. And it tells me I'm going to go up to the right. As x approaches infinity, y approaches infinity. So if I want to graph this, or at least sketch this because it's not perfect, that means that from this x-intercept at negative 3, since it's the far left one, I know my function has to go down. And from this x-intercept at 5, I know that somewhere over here, this function has to go up. Well, what about what happens in between? Well, I know I have to get from this one to this one, from negative 3 to 0, and this is my next intercept. So it does this. And I know that from here to here, there has to be a place where it goes down and comes back up. Now, do I know that it looks like that? Or do I know that it looks like that? I don't know that, and it kind of depends on how I set my units up on my graph. But I do know that it starts here and it ends here. We'll get a little more accurate as we learn a few other things, but we have the general shape of my graph. I'm going to go down to the left, I'm going to go up to the right, and I have x-intercepts at negative 3, 0, and 5. All right, so let's look at another function and see what else we can find about sketching graphs of our polynomials. So this particular polynomial, I want to choose the polynomial, and we'll put it in function notation. F of x is equal to x to the 4th minus 2x cubed minus 8x squared. And again, I'm going to graph or sketch a very simple polynomial, a very simple sketch of this polynomial based upon the things that I know about the polynomial itself. So first of all, let's factor this. So I need to factor out the common factor first. So I'm going to say equals, and my common factor here is x squared. So x squared times x squared minus 2x minus 8. And again, I've picked one that factors pretty easily. So we're going to say equals x squared times x minus 4 times x plus 2. Which gives me, and let's go ahead and say this gives me x squared is equal to 0. So if x squared is equal to 0, what's x got to be? Well, x is equal to 0. So I have my first x-intercept. My first x-intercept is 0, 0. I also know that x minus 4 is equal to 0, which means x is equal to 4. So my second x-intercept is 4, 0. And my third factor, x plus 2 equals 0, gives me x equals negative 2. So I have an x-intercept at negative 2, 0. So if I want to put this on my graph, I'm going to come over and put it on my x-intercepts. I have an x-intercept here at negative 2, I have an x-intercept here at 0, and I have an x-intercept out here at 4. Well, what else do I know? Well, I know that my leading term here is x to the 4th. Well, what is that? That's even, and it is positive. So if it's even and it's positive, I know that this goes up on both ends. And my end behavior here is up, up. It's going to go up in both directions. So if I start off doing that and I mark just that part on my graph, I know that I'm going up on this end, and I know I'm going up on this end. And what about in between? Well, if I try to do what I did a minute ago and I come down and back up to 0 and up, I don't have another x-intercept here to cross back over. I can't do that. Well, so what am I going to do here? Well, we had something special that happened in this particular function. This x equals 0 occurred twice. All right? My 0, 0 x-intercept occurred twice. We say that this means that it had a multiplicity of 2. That means I had the same factor set equal to 0 2 different times. Well, that's kind of important. Factors which occur an even number of times don't cause us to go through the x-axis, but cause us to bounce off of the x-axis. So here, I'm coming down through here. I come through here. Oops, didn't turn my pen back to red. Let's do that. I come through here. I come down into this quadrant, but instead of coming up and going through the x-axis at 0, I bounce off of the x-axis at 0. And then I come back down and back up to x is equal to 5. So that's what my graph looks like. This multiplicity of 2 here, the fact that I had x squared was equal to 0, which means x equals 0, x equals 0. This occurred twice in my function, gave me a multiplicity of 2 and caused a bounce right here in this function. If you have a factor that occurs an even number of times, so twice, 4 times, 6 times, it's going to cause a bounce. Now, it doesn't work that way if it occurs 3 times. If I have a factor that has a multiplicity of 3 or a multiplicity of 5, then that is still going to go through my function and is going through my x-axis and is actually going to go from one side of the x-axis to the other side of the x-axis. All right, so let's clear this and look at this from the other direction. Given a graph, knowing everything I know so far, can I find the equation of a polynomial? Well, I can. But let me point out that we're saying find an equation. Because given a graph, if I don't have very specific points, I sometimes will find one of a number of possible equations. So let me sketch you a really quick graph here, and then we're going to find an equation that could be used to model that graph. So here is my coordinate plane. We'll call this 1, 2, and 3. I'm not going to label the ones that go up and down. I'm just going to leave them because we're going to say we don't know what those values are. And this particular function is going to have these x-intercepts, and it's going to look like this. All right. So there's my graph. So from that graph, I want to find an equation. Well, what do I know? Well, first of all, I know that this goes up on both ends, which means I know that this is of an even degree, because otherwise the ends would go in opposite directions. I also know that it has a positive leading coefficient, because otherwise it would go down on both ends, and it doesn't. It goes up on both ends. What else do I know? Well, I know what the x-intercepts are. I know it has an x-intercept at x equals -2. I know it has an x-intercept at x equals 0. And I know it has an x-intercept at x is equal to 4. All right, so we've got 3 x-intercepts. This particular x-intercept is a bounce. Right? Not going through, just bouncing off of the x-axis. Well, what does that tell me? It tells me it has an even multiplicity. So one of the possibilities is that it has a multiplicity of 2. Now, what else could it have? It could have a multiplicity of 4. It could have a multiplicity of 6. This 0 could have a multiplicity of 3 or 5. So remember, we're finding an equation, not the only possible equation. So if I set this up so that x is equal to -2 becomes a factor, I move this -2 back to the other side. My factor here is x plus 2. X equals 0. My factor here is x. And then I have that as a multiplicity of 2, so that has to show up twice. And then x equals 4 gives me a factor of x minus 4. So there are all of my factors for this particular quadratic. Well, let's put these two together, make this x squared. So now I have x squared times x plus 2 times x minus 4. Well, if I want this in standard form, what am I going to do next? Well, I'm going to FOIL this. So when I FOIL that, I get x squared times x squared minus 2x minus 8. And then last step, distribute the x squared, which is going to give me a function of f of x is equal to x to the 4th minus 2x cubed minus 8x squared. One of the possible polynomial functions which models this particular graph. And notice, even degree, I have x to the 4th, positive leading coefficient tells me that I'm going to go up on both ends. I'm going to have x-intercepts at -2, 0, and 4, and this one at 0 is going to simply bounce off of the x-axis. So we can use this concept we've learned in this video in both directions. We can take the graph and we can find the equation, or we can take the equation and we can find the graph.